Okay, now we're going to do some counting techniques. This is actually a really, really fun section. But you have to know some of the jargon, I guess you should say, some of the symbols and what they mean. For example, factorial. Factorial is denoted with an exclamation mark. Now it means something different in math. 6 factorial, it doesn't mean 6, like just shouting it out. In math means 6 times 5 times 4 times 3 times 2 times 1. So what you're doing is you're multiplying the number by every number that comes before it, every whole number that comes before it until you get to 1. And so 6 factorial would be 720. Okay, if you have an 8384 calculator, you have a factorial button. You would hit math, which is right under your alpha symbol, and then you would scroll to the right until you find PRB, and it's number 4. You should see a little exclamation mark. So you would just hit whatever number you want, like 9, and then you would hit math, and then scroll to PRB, hit number 4, and you'll see the factorial pop up after it, and then when you hit enter, you get your answer. So 9 factorial is 362,880. All right. The next thing we're going to talk about is different counting methods. For example, like what they're used for. Let me clear this off. Okay. So let's say I had a survey, and on this survey, I asked you some basic questions. For example, like your gender. You either male or female. Okay. Then I asked you a question. I don't know. I'm not going to make one up, but the answers to this question could be agree, disagree, or you had no opinion about it. Okay? So I said, hey, what do you feel about this? So you either agreed, disagreed, or no opinion. So my question to you is, how many different combinations of answers can I have? Like, what are the possible answers that I could have situation-wise with males or females? So you have one person. The one person is either male or female. Okay? And then this male could choose agree, disagree, or no opinion. The female could choose agree, disagree, or no opinion. So I have 6 different answers that I could get. Okay? This is called the tree method, listing it out in trees. Honestly, if you have bigger answer choices, I've had like a lot more, trees get kind of complicated, which is why we came up with the multiplication rule. And what the multiplication rule says is just count how many options you have in each category, multiply them, and then that's how many total options you have. Okay? So for example, if you do one for my ladies. Let's say you want to buy a purse, okay? If you want to buy a brand new purse. Some things to consider. In hubbies out there, you can consider this for your wives when you buy them purses. You consider the strap length. Okay? It could be a clutch, which means, guys, that it really doesn't have a strap. It could be just a medium strap, kind of over the shoulder, or you can have a long strap, right? What else can you consider? The size of the bag. If it is a clutch bag, it's pretty small, okay? Then you have those medium bags. You have a large bag, or you can have what I have is kind of like a carry-on purse, like my laptop fits in my purse. You have those. You also want to consider the color, okay? Usually black, tan, white are usually the base colors for purses, and then they kind of splash some, purple or some other colors in there. The length of the strap. No, I already stopped talking about that. What else can we do? Oh, designer. You can consider a designer. Coach. Dooney and Burke. That's one. Dooney and Burke is one. Prada. Louis Vuitton. right? That's something to consider if you wanted something that high end. So, how many different combinations of purses could I make here? Making a tree would be kind of ridiculous, right? Because it would be super, super big. So what you can do is just count all of the options. I have 3 options here, 4, 3, 4. So then you can just multiply. 3 times 4 times 3 times 4 is what, 12 times 12? There's 144 bag options there. And I'm not even listing everything. And there's already 144 bag options that you can choose from. Okay, the next part of the lecture is the big one. You really want to pay attention to this. And it's because we're going to talk about permutations versus combinations. Okay? And to find, hey, how many different permutations can I have of this? Or how many different combinations? It's 2 totally different questions. And if I came, there are also 2 totally different formulas. So if I came to you and say, hey, how many permutations can I have? Easy peasy. Substitute it in the formula, you're done. If I say, hey, how many combinations? You're substitute into the formula, you're done. I'm going to show you how to do that really easily. The problem is, in word problems, you have to decide whether it's a permutation or combination. If you decide wrong, you get it wrong. So you want to really make sure that you know the difference. So I'm going to try to explain the difference between a permutation and a combination. Let's say, oh sorry, didn't mean to make a little mark. Let's say that you had 5 CDs, A, B, C, D, and E. Okay, you have 5 CDs. And you're going to put them on a CD rack. I'm going really old school here. And the CD rack is shaped in a triangle, and it has these beautiful shelves. And on top, on this very top tier, only 3 CDs fit. Okay? So only 3 CDs fit on the top tier. Well, you could take the first 3 CDs, A, B, and C. That is one combination. And then I can put them into different orders on top of the tier. I can do A, B, C. I can do B, A, C. I can do B, C, A. C, B, A. C, A, B. And A, C, B. Okay? This right here, you guys, this is one combination, but it's 6 permutations. Okay? So if I was like, well, give me another combination. Another combination could be A, B, D. That's another combination. Okay? And then I can make more permutations of that because I could just start switching up the order. Ooh, sorry. Didn't mean to write an A. Bad. BTA, DAB, DBA. I think I got on there. So now, this is another combination, and that combination has 6 permutations. Okay, so does that make sense? Okay, permutation, you're just taking your group and you're switching the orders to make different orders of things. But a combination is just one combination. You're just switching the order of it. Okay, so now let me give you the formulas. If you know for sure that it's a permutation, then we need to note it with NPR, which equals, and it's going to be n factorial over n minus r factorial. Now, what does n and r stand for? Well, in this example, n would be 5, because I had 5 CDs to start off with. But I only chose 3, and that's what your R is. I only chose 3 to go in your top tier. So it's how many you have total, that's your N, and then how many you're choosing to switch the order, and that's your R. Okay? So here I have 5P3 if I'm trying to figure out how many permutations I can have. And so that would be 5 factorial over 5 minus 3 factorial. That's supposed to be parentheses, factorial. 5 factorial, 5 minus 3 is 2, so 2 factorial. Then I showed you what 5 factorial means. That's 5 times 4 times 3 times 2 times 1. So 5 factorial is 120. 2 factorial would be 2 times 1, which is 2. And then 120 divided by 2 would be 60. So you would have 60 permutations. And we only had 12 so far. Okay? And you would have 60 total. And that's what a permutation is. That's how many permutations you could have. Now, let's say that we just wanted to know how many combinations of CDs that we could have on top of the tier. Let me erase for some space. Okay. And that would be NCR, n factorial over n minus r factorial times r factorial. Still means the same thing. N is the total number of whatever you have, and r is how many you're choosing to make a combination of. So we would have 5C3 in this case. So you have 5 factorial on top, all over 5 minus 3 factorial times 3 factorial. Excuse me. So we know on top we had 120. We know that 5 minus 3 factorial is 2 factorial, which was 2. 3 factorial is 3 times 2 times 1, that's 6. 6 times 2 is 12. So you have 120 divided by 12, which gives you... Oh, I can hope you see my handwriting there. 10. So there are 10 combinations that you can have of the CDs up there. Does that make sense? Hopefully that makes sense. So some of your homework you're just finding NPR, NCR. If you have a TI-8384 calculator, and a lot of your basic scientific calculators have it too, you should see an NPR button or NCR button. But I really don't know what kind of calculator you have. But if you email me and let me know, I could probably tell you how to do it on your calculator. But let's say that you wanted just to do 5P2. Okay? If you have a TI-8384 calculator, you would have to hit 5, so 5 shows up on your home screen. Okay? Then hit math. If you hit exactly what I'm telling you, you'll go to the math screen, scroll to PRB, and you'll see number 2. And number 2 says NPR. If you hit number 2, NPR shows up on your home screen. So now this is what you should see. You should see 5 and then NPR. Okay? Then hit 2 and enter. And you get 20. So if you had 5 of whatever, we're keeping it really general right now, and you chose 2 and then you just started switching all of the different permutations that you can have 20 permutations. Okay? It would be the exact same thing for combinations. Okay? Let me clear this off. So if I had 10 C5, I have 10, I have no idea, shirts. And I want to know the different combinations if I chose 5. So I'm just choosing 5 different ones every time to find out how many combinations of shirts I could put in my suitcase or something like that. If you did that, same thing. You hit the 10 first, math, scroll to PRB, 10 math, scroll to PRB, and it's number 3. You hit number 3, and the NCR should go on your screen. Then hit 5, then enter, and I get 252. Now, I worked out the ones before, and if you don't have one of these calculators, it is totally fine. You can still do this by hand, okay? And I wanted to show you something. Let's say I had to do this one by hand, okay? And so I know the formula is n factorial over n minus r factorial. So that would be 10 factorial over 10 minus 5 factorial, 5 factorial, okay? If I were going to do this by hand, 10 minus 5 is 5. So I have 2 5 factorials on bottom. So I have 10 factorial over 5 factorial, 5 factorial. Now think about this, you guys. What does 10 factorial stand for? That is 10 times 9 times 8 times 7 times 6 times 5, and that's 5, 4, 3, 2, 1. So that's going to keep going. I'm going to leave that 5 factorial because that's 5, 4, 3, 2, 1. Well, you have a 5 factorial on bottom. You actually have 2 of them. So I'm going to cancel this. So now all I have is 10 times 9 times 8 times 7 times 6. On bottom, I have 1, 5 times 4 times 3 times 2 times 1. Okay, because I canceled out one of the 5 factorials. And then what I used to start doing is I would like, well, I know 10 divided by 5. I know 5 goes into 10 2 times. That goes in 1. 4 goes into 8, so that can change. 8 goes into 4 2 times. That turns into a 1. Does that make sense what I'm doing? I'm kind of like reducing these numbers like if they were fractions. 3 goes into 9 3 times. That turns into a 1. 2 goes into 6. That would turn into a 3. That would turn into a 1. So now all I have in my denominator are 1s. It's gone. And this I can do in my head. 2 times 3 times 2 times 7 times 3. Well, not really in my head, but you know what I mean. Now it's simpler math. 2 times 3 times 2 times 7 times 3. And I get 252, which is exactly the same thing I got if I were to have a TI-83 or one of those fancy schmancy calculators. You can still do it by hand, okay? Okay, let's look at this problem. Suppose Grant is going to burn a CD that will contain 9 songs. In how many ways can Grant arrange the 9 songs on the CD? So, this right here doesn't even have the word permutation or combination inside of it, okay? So you have to decide whether this is a permutation or combination. Now this one's a fairly easy one. I'm going to take 9 songs, okay, and I just want to know how many ways I can arrange them. So I'm just putting them in different orders, and since I'm putting them in different orders, this is a permutation. So when I'm having 9 songs, permutation, I'm still using all 9 songs. So it's going to be 9 permutation 9. And if you do that, you get 362880. 362,880. And that's how many different ways that you can arrange the songs on the CD. Okay? And of course you could have done this by hand as well. Okay, let's look at this problem. Suppose 22 cars start at a car race. In how many ways can the top 3 cars finish the race? I want you to pause it and try this one yourself to decide whether you think this is a permutation or a combination. Okay, this, you guys, is a permutation, okay? You have 22 cars at the start of the race, and how many ways can the top 3 cars finish the race? So let's say I have 22 cars, and I start naming them A, B, C, D, E, F, all the way to 22 cars. Okay, if I want to see how the top 3 can finish, couldn't I just choose the first 3 at first and say, okay, you're going to finish A, B, C. Okay, B is going to come in first, and then AC. Okay, then C is going to come in first, and then BA. Do you see what I'm doing here? I took one, and I'm just switching the order, and I'm still coming up with the criteria that they're asking for. They're asking how many ways can the top 3 cars finish the same race. They never said they couldn't. I couldn't take just the first 3 and work with them for a while, then take another 3 and work with them for a while. So this is a permutation. So this would be 22P3, which is 9,240 different ways that people can come in first, second, and third. Okay, 4 members from a 36-person committee are to be selected as chair, vice chair, secretary, and treasurer. How many different leadership structures are possible? So there's 36 people in a committee, and I'm going to choose chair, vice chair, secretary, and treasurer. Again, you guys, this is a permutation. I would do 36P4. And the reason that this is a permutation is because, again, I could take the first 4 people, A, B, C, D, and that's one leadership structure. But then can I do B, A, C, D? And that's another leadership structure because I have a different chair and a different vice chair. You see what I mean? So you could just take the same 4 people and switch them around and make different leadership structures. So that's not a combination. Okay? So you would do this, and it's probably some huge number. Let's see, what do I get? 1,413,720 different leadership structures that I can make. Okay, so some of you are thinking, okay, Mrs. Seeley, is everything a permutation? What would be a combination? Okay, that would be like if I were to say a soccer team has, I don't know, guys are going to make fun of me, like what, 20 people? There's 20 people on a soccer team. Okay, and once a person has been chosen captain, the next time they can no longer serve. So once you're chosen captain, you can't be captain again, because then that would cause rivalry within the team. So I want to know that you can choose 2 captains, 2 team captains at a time. But once you choose a captain, you cannot repeat captains. Then, what are the different ways that people could be captains? Well, if you choose one and they can't be it anymore, then I can't just take the same 2 people and switch them out and be like, okay, you're the captain, you're the co-captain. Okay, now you're going to be the captain, you're going to be the co-captain with the same people. I can't do that because once one person has been a captain, whether captain or co, they can't be it again. So you want to find the different ones. It would have to be A, B. I could be A, C, but with I mean by not repeat captains together. Maybe I should write them like that. Okay, so it can't be BA. B, C, they could be together. Does that make sense? So it's all in the wording on whether you can group the same people together and just switch their orders. So it's really something that you're going to have to read into, okay? Okay, last problem. The next thing I want to talk about is permutations with non-distinct items. It's the last little tidbit of our lesson. And what this is talking about is, for example, let's say that you're taking 5 classes, and the grades you make are A, let me put these in different colors so you can see what I mean. Are A, you made an A in one class, A, C, and a B. Okay? And I said, great. So what are the different ways that this could be listed on your report card? Okay? So you have 5 slots on your report card, and I want to know the different ways that these could be listed. Okay, well, this is one way that it could be listed. Couldn't another way be A, C, B? Technically, I switched 2 letters, but is it really a different permutation? Okay, because they're not going to put the letters in green and red. All the letters are going to be black. So that's not really anything different. So I want distinct permutations. I want the permutations that are going to be different. Okay, and to do that, what you do is you take your n factorial, which is your total. So in this case, it would be 5 factorial. Okay, and you divide by how many of each different types of terms that you have. I have 3 A's, so that's 3 factorial. I have 1 C, that's 1 factorial. 1 B, that's 1 factorial. And then I compute. So it's 5 times 4 times 3 factorial, because we all know that 1 factorial times 1 factorial is 1, so that's nothing. So it's 5 factorial over 3 factorial. So on top I have 5, 4, 3, 2, 1. Well, on bottom I have 3, 2, 1. So the 3 2 1s are going to cancel out. So then the answer is 20. I would have 20 different permutations because these would count as the same. Okay? So then if I were to give you a problem. Okay. A golf course architect has 6 linden trees, 4 white birch trees, and 2 bald cypress trees to plant in a row along a fairway. In how many ways can the landscaper plant the trees in a row, assuming that the trees are evenly spaced? Well, technically, I could put one of the lindens, right, and then put another linden, and then, or I could put this linden first, and then this linden. But if you think about it, that's the same thing. There's still 2 lindens in the same, like there's still 2 linden trees next to each other. So in this case, I want distinct permutations, okay? Well, then how many trees do we have total? We have 6 and 4 and 2, 12 trees. So that's 12 trees total. so it's 12 factorial, and I have 6 linden trees, 4 white birch trees, 2 bald cypress trees. And that's what I'm going to compute. So I know I'm going to do 12 times 11 times 10 times 9 times 8 times 7. I'm canceling the 6 out, and I'm canceling this 6 factorial out, because this is, on top I still have 6, 5, 4, 3, 2, 1. Right here I have 6, 5, 4, 3, 2, 1, so all of those are going to cancel. So on bottom now, I have 4 times 3 times 2 times 1. I'm not even going to put the times 1. And then here I have 2 times 1. Okay, and then you can start reducing if you need to. Okay? And I get 13,860. 13,860 different permutations of trees that I could have on this fairway. Okay? Well, I hope you have a better understanding of what this is talking about. If you have any questions, just let me know.